Hello friends, Satyendra here, and in this video, let's design the plastic crate in Creo Parametric. So let's get started. So this is the plastic crate, and if you see all around, it looks like this. And to manufacture this part, there are two-phase design. The first design is the part design, and the second design is the mold design. So once your part design is over, this part will be taken as a reference part to design the mold. And to design the mold, we use a different module in Creo Parametric. So we use manufacturing and mold cavity to design the mold. So this is the module we use to design the mold. This is a separate module dedicated for mold design in Creo Parametric. So once your design is over, this is the first phase. The second phase is the mold design based on this part reference, and this mold will look like this. So this mold includes the core assembly and the cavity assembly. So this is the core and this is the cavity. Now this cavity is a split type cavity. So if you see next slide, here you can see this is the core and this is the cavity. It is splitted into multiple pieces. Now this core and this cavity assembly will be used to manufacture this part. So both will be assembled together just like this. So here this assembly is the core assembly and this is the cavity assembly. So once this is assembled, there will be gap in between core and cavity, and that gap is your plastic part. So if you see the CAD model, it looks like this. So this is the cavity assembly and this is the plastic crate. Now the core will come from this direction. So in between core and cavity is this plastic part. So once the mold design is done, the entire assembly will be mounted onto the injection molding machine, which looks like this. So here this is the core assembly and this is the cavity assembly. So both will be assembled together. This core will go inside this, then the molten plastic will be injected and the crate will form. This will be left for some time to cool down, and once the crate is cooled, the core assembly will move out holding the crate. Later on, you can take the crate out by your hand. So this is how the whole process takes place. Now to understand it even better, check the links given in the description. So I have given the two links which will be very helpful to understand the entire process. So go and check the links. So this was the overall idea from design to manufacturing about the crate. Now let's understand other parameters for plastic design. So whenever you design any part, the first parameter is the material. So if your material is plastic, your plastic crate will be designed like this. But if your material is sheet metal, your crate will look like this. So as the material change, the whole design process change. So material is one parameter. Now the second parameter is uniform wall thickness. So for the plastic part, you must have uniform wall thickness all around, and this is strictly followed. So you cannot have variable wall thickness for the plastic part. Now when you see any plastic part around you, you will find that the thickness of all these parts varies from 0.5 mm to 2 mm. So why don't we have a thicker plastic part? So there are several reasons behind that. I'll just explain two very basic reasons. The first reason is whenever you design a plastic part, plastic is having a tendency to shrink. So when the part shrinks, it deviates from its original dimension. So more thickness, more deviation, less thickness, less deviation. One basic reason is this. The second reason is the cooling time. So if the part is thicker, it takes more time to get cooled. If the part thickness is less, it will take less time to cool down. So that is how it affects the mass production. So if the part thickness is less, you can produce more number. If the thickness is high, you produce less number. Now if the thickness is less, to increase the strength, we provide these kind of ribs. So if you see any plastic part which is larger in the size, you will always see number of ribs provided. Now let's see a chart where the different type of plastic listed, and this is the shrinkage value. So this is how these materials shrinks. So shrinkage is also a big factor while designing a plastic part. Now the next parameter is the draft. So if you design a plastic part, you must provide the positive draft all around. So the draft will be always given as per the core and cavity extraction. So for this part, core is moving out in this direction. So as per that, the positive draft will be given. So if you go to analysis, draft check, I'll select the part and then the draft angle, I'll give 1 degree and the direction, I will take the top side. Now we have the draft check to check the draft for the entire part. So now you see here, this is the positive draft. So this purple color, 1 degree is the positive draft. So the face you see in purple is having positive draft. That means your core will easily move out, no surface will stop. Same way, the side surfaces are also checked. So for the side surfaces, the cavity is moving in this direction. So in that way, we can check the draft. So once again, I'll go to the draft. Again, I'll select this part and this time I'll select this face as a direction. So now you see, this face is also having the positive draft. So these are few basic parameters we consider while designing any plastic part. So we'll take care about these parameters while designing this crate. Now let's start the part. And for this, you go to New, Part, Solid, assign the name, uncheck Use Default Template and say OK. Now from here, you select a proper part template. So go with this millimeter Newton second, part solid, this is a metric template and say OK. Now to start this part, first I'll create an extruded block onto the top datum plane, normal, switch off all the datums. Now here you first draw a center rectangle, just like this. Now assign the overall dimension. So this is 600, this is 400. Now say OK. Now this height, take it as 300 and say OK. Now the next feature is this cut. So go to extrude, select this face, normal. Now draw a center line somewhere here, then draw the sketch. So start with line, start like this. And like this. Mirror it with this reference. Now the dimension. So this is 475. This is 40. And then we have this angle. This is 30 degree. Sketch is done. Say OK. Go for remove material. Flip the direction to next. Say OK. Now the third feature is the round. So go to the round, select this edge, hold the control key, select this edge, this one and this one. Now this is 60 and say OK. Now the next feature is the cell. So go to the cell, select this face, hold the control key, select this face and this face. Now thickness I will consider as 3 mm and I'll say OK. So this is how this block got celled. Now the bottom portion, which is this one, So for this, I'll go to extrude. I'll select this face, normal. Now here, first I'll add a sketch center line, just like this. Then I'll go to project, loop. I'll select this face. Now I'll add one line somewhere here, just like this. Then I will mirror this line using this reference. Then I'll go to delete segment and I'll delete this segment, this segment, this segment and this segment. Now I'll add round somewhere here and here, then here and here. I'll make these round equals. Now go to symmetry, select this point and this point, symmetry with this. Now this is radius 25 and this is 100. Say OK. Now go to thickness. Thickness I have 3 mm and the height is 20. Say OK. So the bottom legs are done. Now this center portion I will do later on. Now the next feature, which is a sweep feature, which is this one. So for this, I'll go to sweep. I'll select this outer edge, hold the shift key and select all these edges one by one, all around. Now you go to sketch, normal. Now here you draw a rectangle starting from here downwards. This is 15 and this is the part thickness 3 mm. Now say OK and say OK. Similarly, I have this feature which is also a sweep feature, but for this I need to draw a sketch somewhere here on this surface. So select this surface and go for sketch, normal. Now here I'll go to offset, loop and I'll select this face. Now this direction is correct outside and the offset value is 3 mm. Now just say OK. So you got this outer path to create the sweep. Now you just go to sweep, select this path and go for sketch, normal. Now here you first go to reference, select this face as a reference. Then draw the rectangle starting from here downwards, just like this, because this sweep has to merge with this. Now this thickness is 1.5 because this is not the part thickness, this is the rib thickness. So as per the plastic design, all ribs must be 40 to 50% of the part thickness. So if the part thickness is 3 mm, the maximum we can take is 1.5 mm. Now just say OK. You see, this is merging with this. Say OK. Now this sweep, I will pattern it. So if you see here, this is a sweep coming here and here. Now while patterning, you need to make sure that the last feature should match with this surface. So just select this sweep, go for pattern and here you select the point pattern. So point pattern is a unique pattern which allows a variable dimension pattern. So go to the reference, define, and just select this face, sketch, normal. Now here you simply go to datum point, place one datum point here and one somewhere here. Now the dimension. So this datum point from this reference, this will be 0.75. So the material will be always symmetry with this datum point. So if the material thickness is 1.5, then this datum point will be 0.75 mm away from this bottom surface. Now this dimension is 40, which is given here. This is the 40 mm. Now just say OK and OK. Now see the bottom. So it is matching with the bottom surface. So this rib pattern is done. Now we have this corner rib here. So for that, I'll go to extrude. I'll select this top face, normal. Now here you go to reference, select this reference, then this reference, and this reference. One more reference I need, which is this surface. Now go to project, select this edge and this edge. Then draw the line starting from here till here, then from here till here, same this side from here till here, then from here till here. Now draw a center line from this reference, just like this. Now this angle, make it 45 degree. Then draw one more line, starting from here till here. Let it be parallel with the center line. Now this line, you mirror it with this reference. Now you go for delete segment, delete this segment, this segment, this segment and this segment. Now the dimension, so this gap is 1.5. Similarly this gap, this is also 1.5 and this gap, this is also 1.5. Now say OK. Go to selected and select this face. Say OK. Now go for mirror with right datum plane and say OK. Now you select this mirror and this extrude and once again go for mirror. This time you select front datum plane and say OK. So now you have this corner rib in all four corners. Now the next feature, which will be these ribs. So for this, I'll go to rib, trajectory rib, and I'll select this face, normal. Now you go to reference, select this edge, this, and then this, then this and this edge. Now draw a line starting from here, go like this, then you go like this, again like this, then like this, and then you close it like this. Now here you make this line equal to this, then this. Again draw the line. This time start from here, go like this, then like this, then like this, and like this. Now make all these 4 lines equal. Now draw a center line somewhere here. Select these lines, go for mirror with this reference. Now take this gap 300. Now draw other lines. So start from here, let it be equal, just like this. Then start like this. Same way in this direction. You can even use the mirror to add these lines. So the sketch is done. Now just say OK. Now this thickness is 1.5 and say OK. Now I have this cut feature. So go to extrude, select this face, normal. Now here you add a center line somewhere here. Then draw a sketch. Start from here, go like this, then go like this, and then like this. Mirror this sketch with this reference. Now the dimension. So this gap is 10 and this angle is 15 degree. Say OK. Go for remove material, flip the direction and make it through all. Say OK. Similarly, you have one more cut onto this face, normal. Now just go to project, select this line and this line. Then you go to offset, select this edge, offset 15, then this, again 15, same with this side, 15 and this 15. Now go to delete segment and delete unwanted segments. Add the line, start from here, delete this segment, this segment, this, same way you add a line this side, just like this, delete segment, delete this segment and this segment. Now the dimension. So this gap is 7 mm. This side also This is 7. Go to corner, select this and this. Then this side, this and this. Same way, this side, this and this. And this and this. Say OK. Go for remove material, flip direction and to next. Say OK. So this small cut you have. Now the next feature, which is these ribs. So again you go to rib, trajectory rib, select this face, normal. So once again go to reference, select this face, then this face, then this face and this face. Now draw a line, start from here, come down, then first segment, second segment and then third segment. Now go to equal and make this segment equal to this and equal to this. Now the same way, draw one line segment from here till here and then from here till here, just like this. Once again go to equal and make this line segment equal to this, this and this. Now add other line segment. So start from here, go like this and then let it be equal. So the sketch is done. Now just say OK. Now this thickness is 1.5 and say OK. Now this rib you select and go for mirror with front datum plane and say OK. So the same rib you got this side. Now the similar rib this side. So one more time you go to rib, trajectory rib. Now here first I'll create a flying datum plane which will be 7 mm this side, normal. So now if you see, the sketching plane is inside from this surface 7 mm. Now once again go to reference, select this face, this face, this face and this face. Now draw the line, start like this, make these three equal. and say OK. This is also 1.5 and say OK. Go for mirror to right datum plane. Say OK. Similarly, one more rib I have. So go to trajectory rib and this time you select this face, normal. Now here first I'll add a center line like this, then I'll add a line starting from here till here. This line I will mirror it with this reference. Now the gap between this line and this line is 120. Say OK. This is 1.5. Say OK. Go for mirror to right datum plane. OK. So all the ribs are done. Now we just need to create these cutouts. And for that, go to extrude. Select the back face. So just right click and select the face. Normal. Now to reorient the part, go to sketch setup. And here you change it to bottom. Then flip the direction and say sketch. Now to create the cut, I will first create one line here. I will dimension it. So from here till here, this I will take 8. Then this side also 8. This I will take it 12.5. Now I will go to thicken and here go for single circular. Then select this line. Now enter thickness. So I will take thickness as 5. So 5 is the full gap. So one sided it will be 2.5, half of that. Now I will make this line construction. I will just say OK. Now this you make it 2 next and add taper. This angle you make it 1 degree and say OK. Now select this feature, go for pattern, go for direction pattern, select this face, now make it 6 item and the gap make it 14 and say OK. Now once again select this pattern and go for pattern. Again go for direction pattern. Select this face as first direction and then this face as second direction. Now this is 5 items and this gap is 96.5. This is 3 item and this is 72.3. Say OK. Now you select this pattern and go for mirror with front datum plane and say OK. Now the similar cutout this side. So once again go to extrude. Move your cursor here, right click and select the back face, normal. Once again go to sketch setup, make it bottom, flip it, sketch. Now again draw a line somewhere here Now the dimension. So again, this value is 8. This is also 8. And this gap, I'll take it as 11.3. Now go for thicken, single, circular, select this line, total thickness is 5, and this side half of the 5, 2.5. Now select this line and make it construction. This dimension, make it strong. Now say OK. Go to options, make it 2 next, add taper, make it 1 degree. Say OK. Now select this feature, go for pattern, go for direction pattern, and select this direction. Flip it. Now again take 6 item, gap in between is 14, and say OK. Again go for pattern. Once again go to direction, select this direction and this direction. Now this side 3 item. Now this is 93.7. This is also 3 item. And this is 72.2. Say OK. Now once again select this pattern and go for mirror. This time you select right datum plane and say OK. Now these cut dimensions, you can get the proper value by hit and trial method. Now the bottom cuts. So once again go to extrude. This time select this face, normal. Once again draw a line somewhere here, then dimension. So this value is 8. This side again 8. And this value I'll take 14.5. Again go for thicken, single, circular, select this line, total thickness 5, this side half of the 5, 2.5. Now select this line, make it construction. Now say OK. Now flip the direction. Go to option, to next, add taper. This time you give it angle that side, 1 degree, and say OK. Go for pattern, direction pattern, select this face for the direction. Now this is 14, 6 item, say OK. Once again go for pattern, again direction pattern. This is the first direction, then this is the second direction. Now this is 4 item and this is also 4 item. Now this is 100.5 and this is 75. Say OK. Now the last cut, which is coming somewhere here. So for this, go to extrude, select this face, normal. go to project, select this edge, this edge, this one and this one. Say OK. Flip the direction, go to through all and say OK. So this is the handle and the part is done. Now the only thing left is the draft and the round. So draft will be always given based on the parting line concept. So in the simple word, draft is always assigned based on how the core and cavity will extract. So for example, if I go to analysis and draft check, I'll select entire part and then I will assign draft angle as 0.5 degree and direction I'll select this face. Now you see, this is highlighting that this surface is okay and this surface is okay to move the core out, but these surfaces are not having any draft. So this plastic part will stick with the core. You can see here this color coding, there is no draft with this color coding. So for this face, we need to assign the draft. So if I go to model, draft and select this face, right click, I will select draft hinge at this face. Now here I can assign either negative draft or the positive draft. So let's make this angle as 5 degree. This is the negative draft I am assigning. I'll say OK. Now if I go to front datum plane, section view, I'll just make it section A, flip the direction and say OK. So now you see, this is the negative draft. Now core will stuck here, it will not move out. So this angle should be in this direction, which is the positive draft. So to make it positive, just modify this draft, make it 0.5 degree and flip the direction and say OK. So now you have the positive draft. To check that, you can simply go to analysis, draft check, select the part and then for the direction, select this face. You see, all these inner surfaces having positive draft. Now if I once again flip it, let's flip it. So now it is 0.5 degree negative and say OK. Now if you go for draft check, it will clearly highlight with the proper color coding. Now you see, these red surfaces, this is having a negative draft. So this is how we assign the draft and we check the draft. Now if you see this part, here thickness is reduced because of the draft. Here the thickness is proper. So when you assign a draft to inner surface, you must assign the draft to outer surface to make it uniform. So I'll just go to draft, I'll select this outer surface, right click, draft hinge, again I'll select this surface. This value, make it 0.5, same value and say OK. Now you see, you have the uniform wall thickness. So this is how we assign the positive draft. Now if you see this surface, here the cavity will extract in this direction. So for all 4 directions, there is a split cavity. So that will move to the respective direction. So suppose you need to assign the draft to this face. Then you just go to draft. Now here this face will not stop. This is the stopping face. So if you go for the draft check, you can clearly see. Just select the entire part, and for the direction, you select this face. Now you see, for this direction, if you find a red surface or a white surface, you need to take care of those surfaces. So you can assign these drafts individually for all 4 sides. Now the last feature is the round. So wherever you have the sharp corner like this, you must assign the round. So these are the areas you need to assign the round. Without round, plastic part is not over, and this completes this part. So that's it from this video. So this was the plastic crate in Creo Parametric, and I hope this video will be helpful. Now you can like this video if you find this video helpful, and I'll see you in my next video. Thank you.